All right, hey everybody. In this video, we're going to look at the final two examples of conditional derivation. This is on page 45 of slideshow 16. The title is Harder Conditional Derivation Examples, and we're finally, in this case, going to be able to see why we do the box after we cancel our show line. We're finally in a position to see why that is. So you get to see my big hand again and working through these problems, but I think this makes it the easiest to see what's going on, I hope. All right, so I've already written down the premises of this argument and the conclusion. So we're trying to show Q from those four premises there. And again, this is problem 1 on page 45 of slideshow 16. All right, so let's think about how we might go about this. We want to get Q, and so if you look at our premises, we see that we've got Q in two locations, in premise 2 and in premise 1. But the problem is that it's at the back end of a conditional. So to get that Q out of there, we'd need to either have R in this case, so we could do arrow out, or we'd have to have P arrow R, so we could do arrow out. The problem is we don't have either of those. We've got R over here, but that's tied up in an OR claim, and we don't have anything to sort of break that down right now. And we don't obviously have P arrow R either. We've got P arrow S, we've got R arrow Q, but not P arrow R. So at this point in the derivation, it can feel a little bit like there's nothing you can do. And here's where we have to remember something about this system of derivation that we haven't seen yet. And that is, even though we're ultimately trying to show Q, we are allowed to try to show anything we want that might be helpful for us in eventually showing our final conclusion, in this case Q. What that means practically is that we're always allowed to write down a show line. That is, we can always try to show something. We might not be successful in showing it, but we can always try. And so that's what we're going to do here. We're going to say, hey, you know what would be really useful? It would be really useful if I had P arrow R. So I'm just going to try to show it. And so what I do to do that is I write another show line that says I'm going to try to show P arrow R. So I've kind of got a sub-goal here, which is why I've indented it. The idea is that I'm going to try to show P arrow R. That's my sub-goal. If I'm successful, I'm going to then use that to try to show Q. So we got to kind of keep ourselves organized here. Now, we've got in line 6, we're trying to show P arrow R. That's a conditional show line. That is, the main connective of our show line is an arrow. So we're allowed to do conditional derivation, which we've been working on. So we're allowed to assume P and then show R. So just to be clear, ultimately we want to show Q. We thought, well, if we had P or R, that would be useful, so we're going to try to show that. And because that has as its main connective an arrow, we're allowed to assume P and then try to show R. So now let's see if we can show R. That's our immediate goal. Well, we've got P now, and with P we can take P and add it to line 3, P arrow S, to get S. So that's from line 3 and 7 by arrow out. Now we've got S. If we had the negation of not S, we could get R, which is what we're looking for, so I'm going to double negate S. That comes from line 9 by our DN rule. And now I've got the negation of not S, so I can get R from OR out. So that's from 4 and 10 by OR out. If any of these steps are sort of confusing, oops, I can see I'm going off the page there a little bit. If any of these steps are confusing, please pause the video, look at the rule sheet, and make sure you understand what's going on. Okay, so now we've got R. So what happens now? Well, we were trying to show R, and R is at the bottom of our proof, so we know that that's a direct derivation, dd. So we cancel and we box everything underneath there. In just a second I'll explain what that box means. Now we assumed P, and after assuming P we showed R, so we've shown if P then R, which is what we're trying to do. That's a conditional derivation. So we write CD and we cancel, and then we box everything underneath there. Okay, so now we've shown successfully P arrow R. A canceled show line means we've established that. 6 is now something we have available to use. But we're not done with our proof because, as you can see, we haven't yet shown Q. We've only shown P arrow R. Now, here's something you might think of doing in a case like this. You might think, well, hey, I can get Q pretty easily. After all, I've already got R here, right? I've shown R. And I've got R arrow Q, so I can just get Q from line 8 and line 2 by arrow out. That's not allowed, however. And let me explain why it's not allowed. In line 8, we showed R, that's true. But we didn't really show R in any absolute sense. We were able to show R only after assuming P. So we don't know that R is true from our premises alone. It's our assumption that P that allowed us to show R. So we shouldn't really be appealing to R at this point in the proof. It's not something we really know is true. Similarly, we don't really know that S is true. We don't really know that P is true. P was an assumption and S followed merely from that assumption. So we don't really want to be able to use anything here in our proof. That is, everything inside the box here was merely used to show that if P, then R is true. We don't know that the stuff in the box is really true because it's all based on an assumption. And that's exactly what the box does. The box tells us you're not allowed to use stuff inside of it. Sometimes this is called the Las Vegas principle because what happens in the box stays in the box. So sort of like what happens in Vegas stays in Vegas. The idea is that anything that's boxed up is no longer something we can appeal to. So in most cases, the box doesn't do much because once we box something up, the proof's over. But in this case, we've finished, we've boxed something up because we've shown P arrow R, but our proof's not over. We're going to continue down here in line 12. Right, we're going to keep going through the proof. And what the box tells us is that nothing inside there is now can be appealed to in line 12 and lower. That stuff's off limits now. Okay, so how are we going to go about showing Q? Well, if you look, we've got P arrow R. P arrow R is canceled show line, which means we have it available, and it's not in a box. And in line 1, we have if P arrow R, then Q. And so we can appeal to 1 and 6 to get Q. That comes from lines 1 and 6 by arrow out. So we've got Q. We set out to show Q. And so what we can do is write direct derivation here, cancel the show line, and then box everything there. And again, the box at the last stage, at this point, isn't really so important because the proof's over. But the boxes in the intermediate stages were very important because they showed us that what we were and were not allowed to appeal to. All right. So I hope that makes some sense. Let me do one more example. I'm going to have to switch the paper here. It's my high-tech setup here. With an iPhone dangling above some paper. There we go, though. We're ready to go. All right, let's try one more example of a harder conditional derivation. So premise 1 is P or not Q arrow R. Premise 2 is R arrow S. Premise 3 is R and T. And we're trying to show S and P. And these here are our premises. Okay, so we're trying to show something that's a conjunction. It's an and statement. Whenever you're trying to show an and statement, it's a good idea to try to first show one part of it, and then show the other part, and then put them together. In this case, it's going to be pretty easy to show S. We've got R arrow S, and we've got R here. We can separate from R and T, and we can get S. So let's do that quickly. We get R from line 3 by and out. And then we get S from 2 and 5 by arrow out. Hopefully that's pretty clear and pretty straightforward. We've got S now. But now we've got to figure out how to get P. And that's going to be a bit trickier. Notice the only place that P occurs in our premises is in that first premise, right up there. but it's tied up in an OR statement. So look at your rule sheet to see what our OR out rule says. What you want to ask yourself is, what would we need if we were to get the P out of line 1, what would we need? So look at your rule sheet, see if you can figure it out. Maybe pause the video. Okay, if you looked at the rule sheet, you'll see that what we need to get the negation of this formula right here. That is, what we need to get is not Q arrow R. If we had not Q arrow R, we'd be able to apply OR out to get P. Now, how are we going to get not Q arrow R? Well, we could get that if we had Q arrow R, and then we could apply double negation. So that's going to be my strategy. I'm going to say, okay, I'm going to try to show if Q, then R. That is, I'm going to write down a show line, show Q arrow R, because remember, I can always try to show something. And in this case, if I can show that, I know I'm going to be able to eventually get P. Okay, so this is another one of those subproofs. We're ultimately trying to show S and P, but on the way to doing that, we're going to try to show this. How should we try to show this? Well, it's a conditional, so we get to assume Q. And then we try to show R. So can we show R? Yeah, it should be pretty easy. It's already there in line 3. So we can just write this. R from line 3 by and out. So we've now directly derived R. So I cancel and I box. We've then conditionally derived Q arrow R. So we write CD, we cancel, and we box. And now we're on our way to solving the problem. Because if we remind ourselves here, we got Q arrow R because we wanted to get the double negation of Q arrow R so that we could get P. So let's do that. We're going to proceed now below the box here, and remembering that everything in the box is now off limits, but we still can appeal to line 7 because that's a canceled show line outside of a box. So I'm going to write not Q arrow R. That comes from line 7 by dn, our double negation rule. And now if we take 11 and 1 together, we can get P, which comes from our OR out rule. Finally, we just need to put things together so we have S and P. And we've got S here in line 6, we've got P here in line 12. Putting those together, we get S and P. That's from line 6 and 12 by and in. And now our proof is completed. Again, what kind of proof is it? Well, it's a direct derivation because we tried to show S and P, and that's what's at the bottom of our proof. So we cancel, and we box everything else, everything below the show line. All right, this is by far the most complicated thing we've seen so far in our sentential derivations. So if you need to go back and rewind, review the video, pause it at certain points, or certainly ask me any questions, it's important that we understand how this works.